I would like to take two questions which are there in the chat box, combine them into one question which is apparently of interest, and ask first of all our speakers if they have, our three speakers, if they have some thoughts to offer. And if not, maybe we will refer the question to our experts here. The question can be summed up as follows, that we often start the history of mathematics with Aryabhata. And even if we go earlier, say the Shulva Sutras or other texts, there seems to be a considerable gap before Aryabhata. So what happens, is there such a gap in reality? What is the situation? And it's, of course, a very important question in the history of mathematics in India. So shall we start with Mahesh? Would you have some thoughts to offer on this? It was actually two questions that I combined together. If you are with us, Mahesh? Maybe you are no longer with us. In that case,
hello.
Yes, Mahesh, yes.
Aryabhata himself says he has taken gems from the Sadasajnana Samudra, from the ocean of knowledge. So he might have taken cue from other astronomers too, but he didn't mention any names. And in Aryabhatiya Bhashya, we find various names like Garga and some other names too. So though the texts are not available, Aryabhata might have had the knowledge of those astronomers. So we don't have any evidence about that.
May I make a comment on this point?
Yes,
please.
So of course there are two things. First of all,
no. You didn't attend it. Devanand Malaya, stop it.
But
so Shriram, can you please mute your audio? Okay, thank you so much. Yeah, please.
Okay. So the first point is that, of course, there is the mathematics of the Sulva Sutra, where it is of a very different character, but still there is a mathematical discourse, and it is something that's certainly in the background. So there are indications that, for instance, Brahmagupta's geometry keeps, displays some traces of the Sutra heritage. The second point, which hasn't been properly investigated, is what you get from Jaina and Buddhist mathematics. For Jaina mathematics, the problem is that there are lists of subjects that appear in the Jaina canon, but what we have now is texts that were written probably after the influence of Brahmagupta, so we don't know exactly how much of the Jain canon is really represented by that, but there probably was something that existed before Aryabhata. About the Buddhists, there is another issue, that we have no texts that come from a Buddhist background, and this is not normal because there are Buddhist kingdoms and things like that in India. However, we do have Indian scientists in China in a Buddhist context, and some of them must have arrived around the time of Aryabhata or a little before Aryabhata. And they don't seem to talk about Aryabhata, but very few people have looked at these things, although the Chinese identified them as Indians. There's one very famous example, but I think there is a lot to be explored, and I'm exploring part of this now, but I think there's a lot of room for work. There is someone who's called Chutan Sita, and Chutan Sita in Chinese, it's apparently the Chinese form of Gautama Siddhartha, apparently. And there were three families of astronomers in the Tang Dynasty that were in high positions. And this particular Chutan Sita is very famous because he seems to have made the first survey of Chinese astronomical systems. So the first survey of Chinese astronomical system with critical evaluation of them comes from an Indian. And it is a text that was read, and it contains a presentation of the Indian numeral system with the zero. And there is the text, and it explains that there are things that are written with one stroke, and so, and these things were rejected by the Chinese, but they have kept the text in their annals, and therefore I would suspect that, to the best of my knowledge, these Indian mathematicians in China don't talk about Aryabhata, and therefore it would be interesting to investigate. So there is reason to believe that this gives us an idea of what happened before Aryabhata.
Thank you, Dr. Kitchen-Samy. Would anyone else like to add a thought? What about Kim? Would you not like to contribute to this question, Kim?
I mean, I think so excellent points have already been made. I would just perhaps add to that the idea of the, I think it is quite correct that, the roots of Siddhantic mathematical astronomy and the disciplines that contributed to it, must go back considerably before Aryabhata. Aryabhata is clearly already working in a quite mature tradition in some ways. One of the issues I think could usefully be explored further is possible divergence in different traditions relating to views on horoscopic astrology, and some of the Yavana worldview that will have come along with these coordinate systems and the notions of horoscopes and the zodiac and so on. Was there more resistance to this from a a metaphysical perspective in Buddhist literary traditions than in Hindu or Jain ones? Or, this is a very potentially rich field of textual study that still needs a lot of work.
Thank you, Kim. Would there be any concluding thought for today? Because I believe we will have no choice but to conclude early for once. And tomorrow, then we would have a longer session with 4 speakers, hopefully. Any last thought for today? So if not, then we would like to thank, first of all, our 3 speakers, and they gave us a lot of food for thought. So they show that it's still possible to throw fresh perspectives and fresh looks on established text. Well, in the case of Raja Rajeshwari, it was an unknown text actually, but in a known tradition. And this is in fact exactly what we would like this project to promote. Not, there's already a lot of scholarly work of a very high standard. Some of the stalwarts here present have contributed immensely to that. So the fundamental texts are well known, but there's so much of fresh perspective that can still be thrown at. And as Indranath said at the beginning, what we sometimes miss perhaps is using the modern perspective of mathematics to look more fruitfully at the old processes. And in fact, I would like to remind that the well-known mathematician Manjul Bhargava himself explained how he had found, especially in Brahmagupta and Hemachandra, if I remember well, he had found inspiration for his own work. So it's not that their mathematics was as advanced as his, of course not. In a way, their mathematics was basic by today's standards. Nevertheless, the processes, the procedures that they were following, their approach to some problems still held inspiration and prodded him to find new methods. So therefore, there is still a lot that can be explored, and we hope very much that this younger generation of scholars will contribute to this effort. So, and if there is, would I request my colleagues, Indranath, Atul, or Sudipto, to offer some last thoughts for today? We have some nice comments coming up in the chat box. So I'm happy that people found these talks stimulating. Any last thought?
Michelle, I just wanted to say one line that you were saying about by today's standards, the mathematics at that time might be basic. I mean, the same thing will happen 1,000 years after. So what we are doing probably will be very basic, considered very basic. Though the tools that were available then were so less than what is available now. So it's still incredible how those discoveries were made at that time. So it's really very
Absolutely.
Great job by all these people.
Absolutely. Indranath?
Yeah, I mean, I was listening to the speakers and also to others who were commenting on the work. We were asking very, very pertinent questions. So I will take a different take on this, that so it's clear, and of course it should be this way, that there are fantastic ideas floating around. There are fantastic questions available. So, and this HOMI project, which we have embarked on, is a very difficult project, right? So we all understand that it's not a, it's like any effort here is kind of, we see this, that it should actually be fruitful. It should actually be such that it will give us food for thought for the future. So therefore, if you have questions, if you have comments, if you have ideas, it would be great if you could share it with us, we have Michelle here. So if you can drop an email or you can share an idea, it could be a mini project, it could be a big project. Maybe we can think of some future collaborations with the young scholars, with the experts and things like that. And HOMI platform is there to support that. Of course, I mean, it will be vetted by some experts, and we will take their comments, we will take their suggestions. But this is just to convey that you could use this platform for more research on this topic. Thank you.
Sudipto?
Yeah, I thank all the speakers. I mean, I was listening, trying to understand as a student the wonderful talks and extremely interesting comments. I echo what Indranath has said. I think extremely important. If any of you are interested in pursuing these ideas in a concrete terms, we welcome you to write to us. There are many opportunities within the HOMI initiative, including research position as well as the postdoctoral positions. So if you have concrete projects, of course, these will be peer reviewed, as Indranath has said. But if you have concrete projects, do write to us. At the same time, I request all of you to spread the word that such an initiative exists here, and let people know that what we are trying to do. I also like to share that we are going to create a history of mathematics seminar series from June. And that will be not only the history of mathematics in India, but all over the world. We will invite many people. Unfortunately, given circumstances, it will be an online seminar. But we hope that in later years, once the situation normalizes, we'll be able to attract you guys, all of you, to our campus. So thanks again.
Thanks you, everyone, for these thoughts, and also thanks for our own faculty, other faculty members of the Institute who took part, and some of them, like Professor Chavinath Pandey, just now gave their comments in the chat box. So thanks for joining this. And it was very gratifying that at some point we reached 110 total audience, which I did not quite expect. So that is very good. Someone is asking for the link for tomorrow's session. It is the same, right? So Dipto, it is the same Zoom.
It is the
link.
same Zoom link, yeah.
Yes, and we'll be very thankful if you all join us again. We will begin with Keshav tomorrow, who will give an account of his present work as a postdoctoral fellow here at IIT Gandhinagar, and then we will have 3 speakers tomorrow, and we count on your participation again.
Oh, Michelle, just
yes.
one word.
Ram, please.
Yeah, so at one point it peaked to 110 is not important. At the end you have 85, so that is very important. Okay, so that is one aspect. The other thing that I wanted to just comment was, see, between the various kinds of commentaries, so Indranath wanted, then I was tied up with something else. So at the end of Mahesha's thing, what I wanted to just point out was, certain commentaries try to primarily bring out the mathematical content. But what is so special about this Nilakantha's commentary, which I observed, was it tries to bring in certain very intricate aspects and connections between various disciplines. For instance, he did not have time. So what Nilakantha tries to bring out is a brilliant parallel between 2 intricate concepts in 2 different disciplines. So if you are a real master of Nyaya, so then you will be able to really appreciate what exactly happening. It is like this. So he will just give some upamanam. So it is like saying somebody, if you want to describe, okay, as real Gunda, then if you just simply say he is like Chota Rajan, that is good enough for us, right? So we get the whole thing. So this is what he is trying to do in his commentary. So this is one aspect which I thought I will just bring out, since Indranath wanted a certain comment on the nature of commentaries. Okay, there is some other phone. I'm sorry. Thank you.
Thank you, Ram. And yes, it's a very important remark because when people study Indian philosophy, you know that there are many schools of philosophy in India. Apparently, there is no connection with other fields, especially except perhaps in Ayurveda and such fields. But with mathematics and astronomy, it's not very apparent. And it is true that Nilakantha Somayaji integrates philosophical methods of inquiry into his mathematics, and that makes him quite outstanding. So that was a very important remark. Any further closing remark? If not, so I think that we will invite you again for tomorrow's session, and we'll start at 10 o'clock sharply, and hopefully we'll have all 4 speakers tomorrow. So thank you very much, and bye for today. Thank you.
Thank you very much, Professor Michel. It's a very good initiative.
Thank you, Professor.
Yeah,
Pandey.
thanks a lot. And the speakers also made very good presentations.
Thanks.
They did.